Hi, this is Mrs. Kidman, and in our previous video, we talked about optimization as being making the best or most effective use of a situation or a resource. And in the last video, we talked about how we can use that optimization to figure out what is the most area I can build with a certain amount of fencing, or what is the most area I can use if I have a certain limited resource. Today, what we're going to talk about is how we can use optimization to make the most money, or to figure out, is it even possible to afford something? So let's start by looking at this first one. And this first example talks about buying tickets to a school musical, and they cost $6. And when they cost $6, the attendance should be about 200 people. For every 50-cent increase in ticket price, they expect a decrease of 10 people. So what ticket price will maximize the money that we make that the musical makes? How much money is the maximum amount expected? So that's what we're trying to figure out. So we're trying to look at how much money we make. Money that we make, we usually call revenue. And how do we get revenue? Well, revenue is the relationship between the cost of something times the number sold. So in order to figure out what our revenue is or how much money we need to make, what we have to do is we need to write an equation or an expression that represents the amount that our musical costs, as well as the number of tickets that are sold, or that ticket price. So our cost here is going to vary. So our cost initially is $4, but we're trying to optimize the amount of money that it costs. And so what we're looking at is we're saying, what if I increase it by 50 cents? We'll lose some people, but will we make more money? And that's kind of what we want to figure out. So our cost is represented by the amount of money, not $4. It costs $6 a ticket, plus 50 cents increases. So if I now change it to being $6.50, I have 10 less people come, but do I make more money? Do losing those 10 people really hurt in the long run if I still sell 190 tickets? And that's kind of what we're trying to figure out. So our cost is going to be represented by $6 plus X, where X is the number of changes. So if I change it once, if I increase by 50 cents, will decrease by 10 people. How will that affect the cost? If I increase twice, so I change twice, so 50 cents times 2 is $1. If I increase by $1, how is that going to affect the number of people? Understood? Then we have the number sold, and the number sold is what we're talking about in this case is tickets. So we have 200 tickets sold if it costs $6. For every increase in cost, we decrease, and decrease is represented by subtraction, 10 people. So that X is that number of changes. So if I increase, so if X goes up by 1, so if I do a 1 50-cent change, I go down 10 people. If I do 5 50-cent changes, I go down 10 times 5 people, or 50 people. Do you kind of see how that works? So that X is the number of changes. If I increase my cost, this is how it's going to proportionally decrease the number sold. So our revenue is going to be a combination of those two things. So let's multiply those together and see what happens. So our revenue, I'm going to represent it by R, is going to be 6 plus 50 cents times X times 200 minus 10 times X. And what I want to do is, instead of leaving it in this factored form here, I want to multiply it and write it in standard form. So I'm going to go ahead and do that. I'm going to multiply using my FOIL method. And I get that my revenue is going to be 1,200 minus 60 times the number of changes, plus 100 times the number of changes, minus 5 times those number of changes squared. So our revenue, I'm going to write it in standard form here, is negative 5x squared plus 40x plus 1,200. Now I want to take a look at this graph here. So let's graph it on Desmos. So I'm going to graph our Desmos here. And we are looking at this revenue equals negative 5 times our changes squared plus 40x plus 1,200. Okay, so here is our cute little graph. We're going to zoom in right here. Okay, here is our graph for you. So here's what our graph looks like. This side right here, so I'm going to graph it over here for us. We've got something that looks kind of like this. And what this represents, do you see how those look similar? Our Y variable here is actually going to be our revenue. So our revenue increases until we get to this certain point, and then our revenue actually goes down. And what we're comparing that revenue to is our X, or the number of changes. So I want to figure out how many times should I increase my cost or change the cost, and how will that affect my revenue? And the way we can figure that out is, notice it's a quadratic. So just like we did in those other optimization problems, we want to find that maximum. And we can do that by doing our negative b over 2a. And as we do negative b over 2a here, we're going to get negative 40 over negative 10, or 4. So what this 4 tells us is I need to change 4 times to get that maximum revenue. So what does that mean? Well, to figure out how much money is expected, first we need to figure out what is that cost. So our cost here, really what we're saying when we say change 4 times is that instead of charging $6, I want to change $6 plus 50 cents times 4, because I'm going to increase it 4 times by 50 cents. So really, my maximum cost, my most effective cost, is when I charge $8 a person. And when I charge $8 a person, we can use our revenue equation to figure out how much money we make. So our revenue, when we're charging $8 a person, is going to be what happens when I substitute that 4 changes in here. So negative 5 times 4 squared plus 40 times 4 plus 1200. Well, that is going to be, we've got 16 times negative 5, which is a negative 80, plus 160 plus 1200. And so what our revenue ends up being is we end up getting a revenue of $1,280. So that's the maximum amount of money that we'll make. So we make $1,280 when we charge $8 a ticket. So the ticket price that we want to maximize is this $8. How much money do we expect to get is this $1,280. And it's going to be that way for every cost maximization problem. Is we're looking at the revenue or the income. We'll use both of those 2 words. But basically, we're looking at what is the maximum amount that we're going to make. And we can do that using this relationship here of cost times the number of items sold. So I want you guys to, we're going to look at this next one here, and I wanted you to look at it kind of all together. And then I'm going to give you a chance to work on it on your own. So we're operating a dog walking business. Fan-freaking-tastic. I love dogs. Hopefully you do too. You have 50 customers, and they pay $14 each. Great, you're making good money. Right now, you're making like $700 a month. Fantastic, or a week. But what you're wondering is, if you decrease the price by $1 and you get 5 new customers, how much more money can you make before you start losing money? So what is the maximum amount of profit that we can make? And I want to know, I'm trying to increase my rent here. I'm moving somewhere nicer, and I want to be making $750 a week in income before I do that. So I need to check, is it possible for me to make this much money? And if it is, awesome. If not, then maybe I won't change my prices. Let's figure out what is that maximum so I can be making the most money and see if I can afford this new apartment. That's kind of what we're looking at here. And that's a real life problem that we look at all the time. Is my job making me enough money? Is what I'm doing on the side going to bring me enough money so that I can afford my living expenses? So let's take a look at this. So remember, we're looking at income. Income is the same as revenue. And revenue, remember, is our cost times the number of things sold. So in this case, our cost is the amount of money people are paying. Originally, people were paying $14, but I'm looking at decreasing it by $1 times a certain number of times. I'm trying to figure out how many times I need to decrease it by $1. And the number sold, right now I have 50, and it's going to go up by 5 times the number of times I change it. So if I decrease it by $2, it'll go up by 5 times 2, which is 10, things like that. So my revenue equation here is going to be 14 minus x times 50 plus 5x. Now I want to expand it out and get that quadratic just like we did in the previous problem. So let's go ahead and take a look at what happens when we expand that out. So as we expand it out, we end up getting our revenue is 750 minus 50x plus 75x minus 5x squared. Okay, so our revenue equation here, I'm going to write it in standard form, is negative 5x squared plus 25x plus 750. Great. So that's our revenue. That's what represents it. What I want you to do is I want you on your own to figure out, finding out what is our max revenue. So what is the maximum that we can get? Remember, this revenue, when we graph it, is going to look something like this, where this is the relationship of our revenue compared to the number of changes. And we want to figure out how many times do I need to change it so I can get this maximum revenue. So how can I figure out what that dotted line is? I want you to do that and then answer our two questions. Is it possible to get $750 a week in income? And what is our maximum income that we can reach? So yes, it is because we make this much. No, it isn't because we only make this much. Go ahead and take a couple of minutes, pause the video, figure that out. Once you've gotten it figured out, unpause the video and we'll go over it together. Okay, hopefully you've had a chance to go over this problem. So we stopped there with our revenue equation, and what I wanted you to figure out is what was our max revenue. So the way we want to do that is we first want to figure out how many changes we need. So that number of changes is what our axis of symmetry is for this equation. So our axis of symmetry, remember, when it's in standard form, is negative b, x equals negative b over 2a. So that's what we wanted to figure out here. So we did negative 25, because that's our b value, over 2 times negative 5. We simplified it and we got 2.5. So that means when I change it 2.5 times, meaning I decrease my price by $2.50 to $11.50, that's when I'll make the most revenue. And how much revenue do I make? Well, I figured that out by taking my 2.5 and I actually substitute it back in for all the x's in my revenue equation, and that'll give me my output. So my revenue output that I ended up getting was $781.25. So do I get $750 in income? Yes, because my max income or my max revenue is going to be that $781.25. So I'm making like $30 more than I expected to if I use this max revenue with the cost and hope that that many participants come. And this is a very common application in business to decide how much money should I charge for a product. And it comes down to that relationship between supply and demand. So how many products do I have? How many people need it? Well, if people need it, I can increase the price and less people will buy it, but I'll still make just as much money. And that's what you see in stores all the time. We saw that during this COVID pandemic when the cost of things like toilet paper went up exponentially. It was crazy. Or hand sanitizer, they were hard to find on the shelves because they were in such high demand. People were charging so much for it, but people needed it. And so they were able to charge more and make more money. And this is how they were doing it. So when we talk about optimization, again, there's a couple different ways that we apply it. We see it when we are trying to make the most money that we can. We see it when we're trying to figure out, can I even afford that? What's the most money I can make in this situation? We also see it when we're trying to figure out how much area can I use? How much space can I build with this limited number of supplies? So optimization is so cool. And it's kind of a calculus concept that we use later on, but we can use it with quadratics, which is great. So hopefully you're able to finish this, get started on your assignment. If you have any questions, feel free to reach out to me about how we apply quadratics using optimization.